questions. Okay, so the idea is first explain the Simbots, then explain about the Hycool-IT project. That is the project that involves all the Simbots. Then show you some models we are developing in Simulation X and EcoSim Pro. Is the both software simulation that we are using. The idea is to try to discover the way to use any simulation software with the Simbots. Okay, and then the challenge, the problems we are dealing with that we can find during this time. Then impact project, why Simbot is good for the industry and for the world. And finally, if we have time and we want, we can do a real-time demo, show you what we are doing in direct. I don't know if I can do in direct. Oh, in my computer, yes, but not in the screen. I think we can view something, probably. So, first, why Simbots? Okay, I'm going to... perfect. Oh, the connection is straight. Okay, Simbots. Simbots are simplified, open, and real-time models that represent real market equipment, like a chiller, a rack, or a power transformer. Okay, and this is the basic idea. But they are designed using a standardization with mathematical components. And align with the manufacturer's performance data. So the idea is it's something a little difficult to understand, but then it's really easy and it's a very, very good idea. The idea is the software developers have basic components like pipes, valves, resistance, all these kind of really, really simple components. Then the Simbot use this simple component to create a bigger one. This bigger component is the chiller, the rack, this kind of machine. And for the user, this is a black box. You don't know how it's inside, but this box is working like a chiller, like a rack, like you are buying or you are developing. So this is the digital product passport. The idea in the future is that if you buy a chiller, they give you a digital product passport, you introduce it in your software simulation, and you can simulate anything you want with this. This is the idea, okay? And now we are going to go to the details, okay?
One question.
Yeah.
So in which level of details you go down for a chiller, for example?
Yeah, very good question. It depends. For the moment, we are working in the data centers simulation. So we need only a sample of 5 minutes. So the level of the detail is not really, really good because we are not looking for the errors, millimetrical errors. I don't know how to explain, but very little error. No, we are sampling each 5 minutes. So we want to discover errors that affect the whole system, no little problems. Okay, if there are one problem that it's solved by by their own machine, we don't. It's not important for us. For us, it's important a big problem that affects to all the system in a long time. If the problem could be solved in less of 5 minutes by the own machine, we don't care about it.
But what are the input and output of this component?
Yeah, exactly. We have inputs and output, but the outputs and inputs is given by the manufacturer. Okay, because you are buying the digital passport of the concrete product. So you have the input that the machine have and the output that the machine have.
So, for example, you have external temperature, load, and then you have the efficiency or consumption.
Exactly. That's the idea. And the idea is that you can't modify anything. You only can use. But you can introduce parameters or variables. No, nothing. You only can use it. This is very good because maintain the confidentiality of the manufacturer. So this is one of the I'm telling everything about the presentation, but so don't worry. Then so many computers.
So how does the symbol relate to the digital product passport?
How is
I missed that.
how is related?
Yes.
Yeah, because Symbot is a representation, a simulation representation
Okay.
of the any machine. So this is the related. Symbot is the way to have the digital product passport. Okay, is the simulation element you are going to have.
So digital twin thing.
Is
Like the digital twin.
yeah, more or less. A little digital twin because it's an element that you are using with another element to create a model, a model simulation. Okay. So the origin concept was in the Sfera project, another European project before Diamond or Hycool-IT that we are here talking about, and is applying in construction, and we use it for advanced control and embedded systems. Okay, so here you can view some ideas. Okay.
The SFI project is still there. The website is still going on. I had information because, as you said, there were simulations on both dwellings, but also big industry places.
Yeah. So, need and motivations. Simulation is a key tool in engineering, but in construction is still limited by the time and the cost. I don't know why.
You'll come back.
Maybe I have to call Stefan or no? Hello, good morning, Elke. Yeah. Okay. So, simulation is a key tool in engineering. I repeat again the same sentences. But in construction is still limited by time and limited by cost, of course. So simulation reduce implementation times by an order of magnitude. I don't know if we can solve this problem. Maybe if I put the presentation video like this. Maybe here is not so beautiful, but it's working. Okay, so the idea of the Symbot is needed in simulation and is needed in construction, but we have the problem by cost and time. So Symbot is able to reduce these both problems, cost and time, because you only need to have this Symbot to simulate a wall machine, and of course it's cheaper because if less time, less cost. This is so simple. Okay, so yeah. Simbots are designed to bring real-time simulation in the operation of data center, for example, but you can extrapolate to another domains. Okay? Their main purpose is to simplify the creation of digital twins that can run fast and interact with real system. One of the important thing of Symbot is that we are oriented to real time. The idea is that you can use these symbots in real time, viewing indirect the response. Okay, when you change anything of your computer or your system, for example, input temperature, and you can show in real time what is the results. Okay, this is oriented to the real time. So one other very important thing is that they rely on open standard and beam interoperability. So you can use it with most of the software developers, most of the different projects you have. Okay.
I have a question on the open qualification. So you're saying open standards for BIM. So the model, how you can define the model and then use the symbol. But in the first slide, I think there was what is a symbol? It's open semantic description, something like this. So there was still the name open. My question is the physical library also open, or
No, the idea is that the physical library is not open because it depends of the developer, of the software developer. Imagine, for example, in EcoSimpro, you have a physical library, and in Simulation X, you have another one. And for example, in Dimola, you have another one.
Yes.
So we want to base on these physical libraries, but it's not open because it's from the developer.
Okay, so there is no, let's say, objective or ambition to target also open tools.
Open is the semantic level
Yeah, I
of the
understand.
symbol. Now I'm going to show an example that is very clear, because you can define a symbol with the three different parts.
Okay.
And this is the open part, but know the base, know the library, because
Yeah, I
this is
understand.
from the developer and you can view it internally.
Okay.
Okay. Okay, we continue. So technical, what we are talking about is Simbots are simplified models. They don't aim for physical fidelity, like you are answering for the level of detail. Is not a physical fidelity, but is stability, is mathematical stable. So this is what we are looking for, because we are working with samples of between 5 and 15 minutes. So we need a mathematical stability, but no a perfect physical fidelity. Okay, because in real time, when you are for some simulation at data center, you are not sampling each millisecond.
Yeah.
Yeah, so you are sampling if it's 5 minutes, and you for the worry is the errors that can affect in this time. Okay. Hello, good morning.
No, actually, when I was asking the question about the level of details and not in the time, it's more in the accuracy of efficiency, for example.
Okay,
Efficiency
inefficiency.
curves, depending on so many parameters that can change over
Yeah,
time.
yeah, exactly. All of these things is to be defined yet,
Yeah.
because we are starting work with this, and this kind of workshop or this kind of activities is to share our ideas. And okay, for example, we are thinking about 20% of error in accuracy, but unless it's too much or not, we are trying to discover in this. For the moment, it's not decided. Okay. So the simplification, this symbol simplification, allows a faster convergence in the simulation model, and much shorter integration time. Is the idea we need. That integration is really, really faster, and you can simulate 5 hours in 1 second. Is the idea, because we want to have less cost in time and in money, but in time is the first objective. Okay. So they are designing to be easy to configure. Even non-experts can use it. This allow every people or every more world people use it. No, you don't need to understand what a chiller is working perfectly to use this symbol. Okay. And another important point is that they can detect operational or maintenance issues, acting as a smart assistant in supervision, but just supervision. Okay, no detect internal little problems. Um, then another very, very good features that I said before is that they respect the manufacturer's confidentiality. You don't need to know how the manufacturer configure their machine to simulate this. And they develop in joint effort between researchers, manufacturers, and software developers, ensuring the compatibility with different tools. Is the way, the thing that we want to use it in DemoLine, EcoSim Pro, in Simulation X, in all the different software developers, because it's working to a standard. Okay. And this collaboration is key to creating an open jet security standard for simulation across over the industry. I'm going to try to put the presentation big again. Okay. So Simber are built on an open representation available to all vendors using the O4B SIM ontology and knowledge graph. These ensure consistency and transparency. These allow direct open interoperability with BIM and IFC project, linking geometry and simulation in both directions. So this is the idea to create a standardization and interoperability with another system. It's really, really important to have future with this. And here we can view the standardization idea and why we are saying that Symbot is open. You have the Symbot code, for example. This is one font that we created in EcoSymbro. And you can view here in the top side, okay, here, you have the library that is used in EcoSymbro. Okay, here you have the ports and the table. And here you have the equations. You can view the schematic here, libraries, components to inert, ports, tables, and equations. So you can create any symbol you want, because the idea is to find people who collaborate with the creation of all the symbols and all the digital product passport. This is for the future, because in this moment we are developing the idea, but this is the way to create. If you have libraries for any software developers, you can try to create this symbol. You only need to know what is the port, the tables and the equations, and you can create any symbol you want. And this is why we are saying that it's open, because it's really simple. You don't need to know all the details about the machine. And every research can create a symbol.
So which means the equations, these are the macro behavior of the component
Yeah, exactly.
based on the
Exactly.
micro.
Yes, because for example, for a fund, if you have the transference equation, you have everything. You don't need all the information that manufacturer is giving you, how many resistance or little components they have inside. It's not really important if you have the equation, the transference equation. Okay, so this is the idea, to create a different machine with just equations, ports, and tables if it's needed. For example, for fluids, it's a little bit complicated, and you need tables probably. But the idea is to use only the equations, okay, the transfer equation. And now we are talking about the Hycool-IT project.
Yes,
Sorry,
well,
sorry.
No, it's okay. Maybe I have a question about confidentiality to understand this equation that will be something provided by the manufacturer.
Exactly.
So in terms of confidentiality, we are not supposed to see these equations, right, or not?
Yeah,
I
but
mean, I'm not sure I understood the whole concept of developing a code. Okay, we open, let's say, an architecture to welcome any equations, etc. But how do you manage to keep confidentiality of the manufacturer and integrate the component in the whole tool?
yeah, because the manufacturer is giving you the behavior of the company, not how they build the component.
So he gives this kind of equation.
Exactly. Yeah. Of
Okay,
course.
okay. That's, now
For
I
example,
understood.
in a data sheet or something similar in a manual, they are saying you this graph is showing the efficiency or the head transfer, depend on the components, of course, and you get this equation. So the little elements from the machine is completely secret. You can't view it.
Okay, but at the end of the day, I can make some comparison with all this code. Let's say I have two fan manufacturer. I can compare the power consumption of the two manufacturers and draw some conclusions, right?
Mhm.
Yeah, okay.
Yeah.
Okay.
Okay. So this is involved in the Hycool-IT environment project. Hycool-IT is another European Horizon project aimed to develop hybrid cooling system for IT infrastructures. It integrates digital management or real-time simulation to optimize efficiency in data centers. The duration of the project is 36 months and starting in December of 2023. Okay. This project have different partners. Here you can see some of the partners: the Polytechnic of Milano, CNR, IDP, Sorsion, the VDTA. This is us company. The Institute Mihajlo Pupin. I don't know how to pronounce this. European Innovation Marketplace, Comet, and Artuya. Okay, this is the partners. And then we have the key connection. something different because beyond the project partners, Hycool-IT relates to several strategical initiatives in Europe. And for example, the Barcelona Supercomputer Center link the project with the high performance computer for energy optimization. This is one of the models we are going to view later in the demonstration. And we are working on the chillers, the racks, and the complete system of the data center, the Barcelona Supercomputer Center. Then EcoSim Pro and Simulation Egg, this one are the both software developing we are using right now. We want to commence just to work with Dimola too. And then Technalia, through the Datia project, it's another European project, collaborates in the definition of ontology and real-time data semantic. And these connections ensures that Hycool-IT outcomes are compatible, scalable, and aligned with ontology and with ongoing European initiative. Okay, and here you can view a global idea of where Simbots can use and is using during this time. Okay, Technalia, Barcelona Supercomputer Center, and in the other side you have the softwares and the standardization we are working for. The CEN 442, this one is the standardization we are working. Then now we are going to see some models, and here you can see in Simulation X the rack model. Then at the end of the session we can view in direct in the computer, but I don't know what is the problem with this.
I think that's the connection.
Yeah, but so this is a rack, and here you can view the different lines where you only have a fan, a heater, and that's all, because the rest are boundary condition, so it's not really important. You have a volume and another volume. So the air enter to this volume, the fan moves the air by the line and get out by the other volume. And during this time, the air is heated. So this is the symbol of a rack. It's so simple because a rack is a machine. Yes, it's a very, very complex machine. But for us, in this case that we are studying the cooling, for us, a rack is just a machine that get air, heat air, and get out the air. It's so simple.
Mhm.
So if you have the equation to know when I heat the air and how I heat the air, I know everything, and I can create a symbol. And this is the way that we create the rack. In this case, it's in Simulation X, and we have the same. And we have the same model, but in EcoSim Pro. This is Simulation X, and this is EcoSim Pro. Like you see, it's the same, but in different software developers. This is why they imagine the photo is different. Okay, here you have the volume, another volume, where you are heating, and then the fan and the other volume. In this case, Pablo is working in EcoSim Pro and I am working in Simulation X. And this is why I do the model from the left to the right and Pablo to the right from the left. So it's different, but it's the same model. Here we start in the front volume.
Mhm.
We have the fan and we heat the air and we have the rear volume. It's the same. If you compare it, oh, bad idea. Okay. If you compare it, it's the same, but in different direction.
Yeah.
Okay.
One
Yeah, yeah.
about the inputs and the parameters varies over time. What is it? Because here you have the heat release, basically. But is the heat release related to some data processing or?
For the moment, this is something that we are trying to discover. For the moment, it's just a test. This idea is starting. Not the idea, but the developing in software system is starting. So for the moment, we are doing different tests. And in this case, we are heating the air because we want it to be different tests. For example, I want to increase the air in 20 degrees, for example, to try to discover how the whole system is working. But the reality, you need to know in the manufacturer. They have to tell us, okay, the difference between enter temperature and finish temperature is tal, and this value is that you need to heat the air. Okay, but for a moment we are doing tests only. So we don't know exactly values in some things. Another things is perfect. For example, here you are viewing 6 fans, but the reality, the racks have 8 fans. But to simplify the simulation, we are using only 6. Okay. The idea is try to use only one fan that represents the 8. But the problem is a very big component, very big, well, a very high speed, and the convergence have some problems. So this is why divided in more lines, okay? More different lines. Yeah.
Because actually, the heat release and volume and temperature, that's a known equation. So mc delta T. So if you know how much heat is released, then you have just volume and temperature. So one fix the other.
Yeah, yeah.
So-
Yeah, but here you need the rest of the system. This is like a little
Okay.
part, and this volume is connected to another part, and you need to study all the fluid, because you can't study only one volume because it's a complete. Now you're going to see the complete model, and it's easy to understand. Okay. Then, before to see the complete model, this is another example. For example, the in-row cooler, where you have a flow source here, because this is two sides, the air side and the liquid, or in this case, water. It's not just water; it's water with glycol, but in the sample it's water. So, by the left side, you have the air, and you have just, in this case, a flow source, some different volumes, and in the middle a heat exchange. And oh no. And in the left side you have the water part with different sensors in both sides, but it's just to get information for us. And here a 3 ways control valve is to get a bypass, and you can configure the valve to decide how many water is in the main circuit and how is in the bypass. And exactly the common heat exchange. This heat exchange is something difficult because it's mixing two fluids with all the fluid equation in different solvers, in different developers, and this is something that we have to work in common with the developers because it's something difficult and strange. And here we have, or not, yeah, here we have the same example but in EcoSimpro. Okay, we have the heat exchanger here, okay. Okay, instead of flow source, they have a fan. It's more or less the same. It's just to get a easier simulation in Simulation X because it's more complex. And the different, in this case, Pablo introduced some pipes. Okay, to try to view the circuits and the three waves valves the same. So the circuit is the same, but in EcoSimpro and Simulation X. And we are trying to simulate the same circuit, the same model, in the same condition, and try to discover if the results are the same. For the moment, it's really similar, but we are working on it. Then we create some tests. In this case, you can view the rack symbol. This is a symbol of the rack. The slide we see all the different lines is inside of this block. So this is what the person who is getting from the digital product passport, for example, in case of a rack. Of course, this is our first prototype, so we have to get better, of course. And here you have the 4 racks and a row cooler in the middle and the 2 volumes, just to study the temperatures. And this is from the air. The red side is air, and the blue or green is liquid, is water in this case. And you have a tank. This is just a trick, but to know how the in-row cooler is working, we are heating the liquid in the tank. Okay, to try to here the liquid is, for example, 20 degrees, or no, 7 degrees. 7 degrees is the parameter. And when passed through the in-row cooler with the air of the rack, it returns to the tank at 20 degrees. And this is what is discovering. So in this case, this is not heating, it's cooling. Sorry, it's cooling the water.
Yeah.
In the reality, it's not. This is only a test. This tank doesn't exist. You are to cool the water in another machine, not here. Okay. Then another test is the same test, but in EcoSimpro for racks and in row coolers, both volumes. And here you have the tank, the fan, and in this case, Pablo is cooling the liquid in the pipe. I was cooling the liquid in the tank and Pablo in the pipe, but because this is only a test, so you can cool in the water when you want. In the reality, of course, is not. Then this is the part of the complete model. Here you can see one line with 3 row coolers and 7 racks in the volumes. This is like a part of the complete model, that this is the complete model. Okay, with 4 different lines and all the pipes, all the volumes. This is why I was saying that you can study a volume for its own. You need the complete model. This includes chillers, hydraulic distribution, racks, and in-row coolers. Okay? So the idea is to have this in Simulation X and in EcoSimpro and compare it. And then elevate this to the real time. With OPC UA, these protocols, we want to communicate this with the pilot in Barcelona and compare the values in real time. Okay. Then, challenge. The first part of the challenge is related only with the simulation. So, model development, finding the right level of simplification to make the model functionality, but computationally light to be faster, if not. Then the mathematical partition, define efficiency partition to reduce stiffness and speed of simulation. Convergence and solver. Ensuring numerical stability and accuracy, a specialty with incompressible fluids. This is one of the biggest problems, the fluids, because each developer treat and is using the fluids equation in a way. So we need a standard for this. It's not nothing that don't exist. We have a standard for fluids, but not all the developers use the same standard. So this is one thing that we have to align, because we need it. If not, this is completely, for example, then I'm going to show you about the fluids, but in EcoSimpro, they are using 2 standards, and you can use another one. But EcoSimpro is not saying nothing. You don't know about the fluids. You don't know if they are using a standard or not. So this is one thing that we have to work, and we have to decide in common with the developers, because if not, this is not working. Okay. Results analyze and consistency. verifying results and checking coherence with physical behaviors. And finally, real-time simulation integration, connecting the models with BMS or DCMS system under real time. This is what I am saying you, but in this moment we are working on the OPC UA protocols, but there are another, and I don't know if this is the definitely protocols or not. Probably, but we don't know. Then another challenge part is how the structural challenge we discover in the Simbots. First, property tables. This is related with the slides we saw with the code. Okay, they contain all the constants and general parameters defined by the developers. This is what you are asking about the equations, the tables, and this is the property tables that we need. Then the fluid definitions. Fluid must be correctly defined, whether income, EOS, this is the standard. The standard. For example, Simulation X is using these libraries or this database to use the fluid, but EcoSim Pro, we don't know. Probably yet, but it's not specific in any part of the software. And of course, the thermodynamical properties must match the traverse and ensure the realistic results. And the basic libraries, each developer provides their own libraries. The basic libraries must have the same components like tube, valves, fans, pub, the low level, which act as the foundation for the high level symbols. Okay, and the abstract component, these are adaptable templates that can be linked to different property tables, allowing flexibility without breaking the general methodology. Okay, this is all related with the slide from the code and the blank code, the code to complete. Okay.
Yeah.
In the workspace integration, this is the environment that combines all the previous. So we need a workspace that combines all the problems or all the solutions. We need the property tables, perfect. We need the flows definition. We need the basic libraries, and we need the abstract components. And when we have this workspace complete, we have the Symbot environment created. Okay. The impact in the world or in the manufacturers industry, the first key impact of Symbot is the simplification, because reduce all the complexity and all the time. But first, the complexity is so easy to use this element. If you don't need to be an expert to try to use this Symbot. Then reduce cost and time. This is really important in this moment because you can simulate anything in one day. For example, in 3 hours, one technical, nor an HVAC engineering. No, just simulation engineering, and not in hydraulic or pneumatic. No, general engineering can simulate something with this in, for example, 2 hours, 3 hours. If you don't have this and you can simulate all the machine with all the elements, probably you need 1 week, 1 month, it depends. So reduce costs and reduce times. It's fast and stable. Have the possibility of real-time integration. Oh. Then we are working through a standardization. So it's open method and common method for all the different simulation engineering. Then they have interoperability with BIM and other domains. Is the idea to have a perfect interoperability with the domains we work during our work. And supporting for EA monitoring. This is the next step. When you have the real time dominated, you can introduce the EA. Okay. And from my side, that's all. So thank you for your attention. This is the global idea of, but not global, the detailed of the Symbot. Of course, this is a technology to develop. It's not finished. It's not all decided. This is preparing for have a conversation with the manufacturers, with the developers, and discover in common the way to finalize this standardization. Okay. Because it's so easy, and of course, if this go to the right way, is the future. But we have some problems by the way, of course. So I don't know if you have any question, anything you want to. Yeah.
No.
Fausto.
Where you had a little short demonstration or something?
Yeah. Now I'm going to show you some things. It's complex because I can connect my computer to the screen, but I'm going to move from this side, and we see in my computer.
So just one thing to see if I understood correctly. The idea is to use the Simbots inside the simulation tools, right? So only you can use the Symbot as a module inside EcoSim Pro,
Exactly.
but not like in a custom software you build.
No, you
Okay,
can
so
use
you-
the Symbot in any software you have. Simulation X, EcoSim Pro, Dimula, or what you have. The idea is that you get like a file that you can introduce in your software system, anything you have. This is why we need that all the software developers are aligned in the same basic libraries, in the same protocols, not the same languages because it's not necessary, but yes, the basic library at least. Even the names of the pipes because if we don't have the same name, we are completely lost with the tags. Okay, so
Sorry.
no, don't worry.
And as you said, it's the begin. You're still like beginning to work on it. Are you having a hard time talking to software developers, or is it like?
Yeah.
Do they like the idea, or are you having a hard time?
Yeah, we need to have this time to talk with the developers. Now, Simulation X, my previous work from UDA, it was Simulation X. So this is why I am working with Simulation X. I know because I was a software developer of Simulation X. And this is why about this software I know. But for example, here I don't have EcoSim Pro because it's Pablo domain and not mine. I'm going to show you in Simulation X different models. But then the part of EcoSim Pro, I'm going to show you a deck. Then I explain you later, but it's completely different. For example, here.
Mauricio, you can come and. It's only 6 of us, so I don't think anybody will mind.
Okay. It's so simple for now. I don't know if all of you can view the screen. I'm going to put it bigger. And here you have the rack, okay, with the different lines. Here the complete rack. Here you have the entrance and the exit in the other side. This is not prepared to small screen here. And like I say in the presentation, you have the fan, the heater, in this case. Okay. Today, the technology is giving me a lot of problems. Okay. For example, here the heater is, no, the heating. Okay, it's only one, but I don't know, it's really, really small. But here you can pull or you can heat what you need. For example, okay, what you need. Here you can heat. In this moment we are doing my pads. Okay. And this is just a valve to maintain the fluid stability. This is one of the Simulation X characteristic. And in EcoSimbot, we don't need to do this, but in Simulation X, yes. And this is the boundary condition to try to establish the first part of the fluid in 25 degrees in this case, but you need it. If not, the model is not converging. Okay, and if we simulate this, we have the results here. And you can view how the from volume temperature is constant and the real volume is getting the temperature from high. It's a constant temperature because now here we are not using the rack like in the market, like yes, this is the question you made before. You are heating, just heating. So it's a moment that the temperature is constant. This is no the good way to do to do this, but we are waiting for the response of the manufacturer to create the correct transference line in temperature. Okay. So this is one of the,
And here, can we change the heat release and correlate it to, I don't know, the number of research, Google research, etc.?
yeah, you can do it. Yeah, no problem. So inside, this is the rack Simbot, and if you use here in a new model, I can use this element that is, sorry for the size, is really small. If you use this is a rack, a symbol of rack. And if you open the component or open the element, you can view the rack you have it. Yes, this is the idea of the symbol. You have a big box, and inside of the box you have all the elements.
But that's hidden for the Simbot user.
Yeah.
That's what
Yeah. This is not viewing. No, it's not for the symbol user. It's secret.
That's for the manufacturer.
Yeah, it's for the manufacturer. Exactly. This is why we maintain the confidentiality, because this is given by the manufacturer, but the user is not saying anything of this. So it's the good part. It's another good part of the symbol. You give the opportunity of use your element, but you are not discovering your cards.
So the user, though, he sees the big box and the equations and the ports.
The equation on the board is for the manufacturer. If the manufacturer can create this big box, they have to use the equation of the manufacturer, but the final user only needs this. The final user don't have to care about the equation, about the parameters, about the no.
They can see it.
This is something that we have to decide.
Yeah.
I don't know yet. Probably, yeah. I think yeah, because the manufacturer is going to give you a manual or a data sheet so you can view all the parameters. You need it for your model. So probably yes, but this I can say the final. I don't know.
The manufacturer provides that as a DPP.
Yeah.
Okay.
Yeah. And for example, the other element that I have is the in-row cooler is same another symbol, and if you go inside the component, you can view the schematic of the. So this is the idea. And imagine that you can have some elements, some kind of elements like this for all the elements in the industry. You buy any machine and you have this. You can simulate it in one moment.
And can it be a fractal system? Like you have a symbol for here the rack, then you create a symbol of data center.
The idea is to create a data center by Simbots, but the problem is that rack or in-row cooler is created by one manufacturer, but the data center includes a lot of manufacturers. So it's really difficult to have a symbol from the data center in only one step.
Yeah, I know,
It's
of course.
complicated. So yes, you can have different little symbols of different manufacturers. One from the rack, one for the raw coolers, another one for the chillers, and then a bigger symbol of all the data center. But the complete data center is you need engineering to do the little symbol and connect it all the little symbols to have the big one. But yet you could have it if you have the little ones, the different machines symbols. Okay, this is the global idea. It's really good, but is a little
Yeah.
bit far.
Yeah, but if you have the standards, then you can, go on.
Yeah,
different
if we
levels.
have the standard is to go in different levels, of course, but we need to work in the base standard first. First, from the moment the idea we have it, but now we have to talk with different the software developers blah, 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 are the biggest problem.
Okay.
Because if you see the Cosimpro environment and see this environment is completely different. They don't have anything in the same way, so it's like, wow, I need only the basic component, but they have to know the same name unless, because if not,
Yeah.
I don't know how to reference to this element. So this is the first step. But we need to go to the developer with something. So this is the previous word to say, hey, okay, this is my idea. We need your help.
That's why the meetings with the center, working groups and all that.
Exactly.
And how many software developers are in software vendors? Are
For
in-
the moment, 3. Ecosimpro, Simulation X, and Dimola for the moment. And we are open to new software developers, of course. We need all the most of possible. This. One more, better, of course.
So these are research software. These are not commercial.
What?
The software so Ecosim, etc. They're not used by engineers or designers, do they?
Oh, yes. Well,
Yes.
Dimola, I would say yes for Dimola.
Simple too.
Okay, never heard of that.
I don't know. Pablo is working with Dimola. I don't work with Dimola.
Dimola is the, let's say, a commercial version of Modelica. Well, one
Okay.
commercial version of Modelica.
Yeah, Cosimpro and Simulation X is based on Modeli. I think Dimola.
Oh, as well. Okay.
And the difficult part is to know if there are another software development that is not based on Modelica. It could be work with this standard. This is one of the things we have to discuss. Because I don't know if it's possible. All of this is based on Modelica, no problem. It's the same technology for all the softwares, but if we change.
And are you thinking about, let's say, an intermediate modeling stage that will be to design the input and outputs of what is a symbol in order to have only one definition for the manufacturer point of view? What I want to say is if the manufacturer has to provide his equation or tables for Ecosimpro, for Dimola, etc., then it makes the let's say the engagement of the any manufacturers complicated. So are you thinking also about having only one I don't know how it could be, but one informal standard of description of what is the symbol, what are the frontiers, input, outputs, because I suppose if it's not temperature, flow rate, pressure, humidity, I don't know. If it's not the same for any for every simulation tools, it might be complicated to involve the manufacturers to they cannot have experts of all simulation tools keen to develop.
We know it's difficult, but if you go to a manufacturer and say, okay, you have to do this symbol for it's a lot of work. It's not interesting for me because you are adding me a lot of work, and I don't need it because I'm giving you the data set and it's your fight. So we want to discover a way that it not involves a lot of work for the manufacturer. It's just something simple, something easy. But yeah, it's a problem. It's something we have to discuss, something we have to discover how to do it, because we know it that it's difficult to get only one specification for all the software. We know it. But maybe we can, the idea is to involve in the developers, because we can create some task between the information that the manufacturer gives from the software developer. So if you get an intermediate, something like an interface or something like this, I think this is the correct way. But we are we are working. Imagine each developer can create an interface. I don't know the Modelica. Okay, that you can get the information that the manufacturer is given and transfer into your own environment. And this is done by each developer, each software developer. Nobody manufacturer, because if you put all the work in the manufacturer, he's going to say you like it's not interesting for me because you are adding me a lot of work.
Yeah.
So I think it's better to separate the work. For the manufacturer, one thing. From its software development, one thing too. The interface to transfer the manufacturing information in our environment needed. But we are discovering all of these things, and this is why I say that it's a very good idea, but it's in the far. It's far. But it's very, very good because it's really faster to do the things. And here I'm going to show you the real time. Is the last demonstration, because in Simulation X here you can see the environment, the different symbols we have created for the moment, just to define them, because I have a lot of different, but it's this with a CEPAM, for example, and here is related with electricity, because we was creating we are working on that, so many things at the same time. So here travel, always. Last one, this one. Here we are working on a truffle, and we need to create the symbol of this. This is a three-phase transformation of electricity. Sorry. And here we are working in another symbol, but it's not finished. So this is why I'm also using the complete symbol. Okay, and this is connected in real time with OpenCUA, like I said before. And in EcoSimpro, I can show you, because I have prepared it in Simulation X, I can show you, but in EcoSimpro, yes, I can. I'm going to show you what Pablo have. Here. Okay, in EcoSimpro, when you have finished your model, you can create a deck or an application, and you can run this application in any computer. And when you open the application, you can introduce values and you can view results. It's not very visual for the moment because we don't have enough time, but we are going to analyze the traffic, the protocol traffic. Okay, we are going to see it, but it's not so beautiful. Okay. Okay. Okay, so this is the EcoSimpro bigger project that we see before in the presentation, but running in background. Okay, and I have all the different variables and parameters here. So, okay. I don't know if oh yeah. Here you can view the time stop. The time is in this moment the simulation, temperature in one of the volume, temperature in another one, the valve, the bypass, the three-way valve, okay, is in the middle position, in the half, and the cooling heating. The heating in this case is cooling. Okay, so this is the variables we are going to analyze in the Pablo's model. Okay, to communicate with this, we are working in OpenCUA. What is the Okay, it's running. I don't know. It's running. I'm going to check. This is US, and this is an interface to what time? Why what time? And here I have connected, yes, connected. And here I can view all the values. That is really, really, I can put it bigger, but okay, here I can, first I need to reset, so I'm going to put a 1 and run. And if I run it, here the time now is 0, 1, because we do one step. Here the temperature is less 20, 19, okay? Do you see it? And for example, if now I decide to cool it in 7,200, for example, instead of 5, and I run again, why is not running? No, sorry, it's this one. Now it's 0, 1, 2, or not? Why not? Why not running? Okay, I'm going to start again because I don't know what is happening. This is why I don't like the demo lighting.
The demo
It's
effect.
horrible. Nothing works when you are so in
Yeah,
lighted.
it's brutal.
Okay, it's running again, connect. Then reset. No.
And when I do demos, just record it.
Yeah. It was my idea, but again, 0.1, 1, and run again. No, it's the same. Okay. It's not working. I don't know why it's not working, but the idea is to move here the variables and get it the result in this tree. Okay, it's working. Yesterday it was working, but now it's not working. I don't know why. And then the next step is to view this in Node-RED. I don't know if you know Node-RED. Okay, I'm going to show you on the internet. One moment. Node-RED is an easy viewer of OpenSea protocols, and you can connect yes, it's a dashboard, exactly. And here you can view different parameters, and the results is so easy to do, but we don't have enough time to do the different things. And the idea is to control the simulation by this one, okay, by this software. So in EcoSim Pro is prepared, and Simulation X is prepared yet, but this is another problem that we have, because for example, EcoSim Pro, you can create a deck and you can search with all the people, but in Simulation X, not. In Simulation X, if you want to run this deck, you must be the license in your computer. If I say with you my deck from EcoSim Pro and you don't have a license in your computer, you can use it. And the other option is that, okay, it's the same option as EcoSim Pro, but you have to pay a lot of money. So if you want to say, okay, you pay. So for the moment, our license is limited. It's not it's complete, but don't have this option. So for the moment, we only can do the demonstration in my own computer. But the idea in the future is to talk with the developer to say, okay, if you want to do this, you need to open the possibility, because if not, I can show anything from Simulation X. And I think that's more or less all the information I have for today. I don't know if you have any question, any idea, something.
Yes, maybe about the final use. Let's say when it comes to connect the Simbot to the real-time system, what is the use of the Symbot? Is it does it deal with running over one period for predictive simulation, or what is the expected output from the user point of view of the Symbot once it's connected to the real-time monitoring system?
Finally, the idea is to create a digital twin. So, for example, of the data center of the Barcelona supercomputer, is the idea is that you can simulate with real data what is happening, and you read all the data from the real building in this case,
Yes.
and you simulate it. It's not the same. It's not sharing the elements, but you have your simulator in real time,
Yes.
and you can discover an error that you are not monitoring in the real building.
Yes, but well, I have I have all my states in all the measurements I have. I can give it to the simulation. It's working in real time. But what kind of additional information can I have if I don't know, simulate over one period further? Or, do you see what I mean? I'm not sure I understood totally what's the added value of the simulation.
You can prevent. You can know the problem before it happens. This is the idea. Like machine learning, something similar. This is the idea that you have a digital twin that can prevent an error or a fail that you are having or you are going to have in the building. This is the.
Okay, so it's more about fault detection and diagnosis more than doing some predictive